Okay, I've built up a circuit which simply takes the previous outputs of the combined switched outputs of the power supply. So the green wire from before, and the green wire now runs over to the plus side, plus labeled input of the op amp, the TL081. I have looped back on this white wire the outputs over to the minus-sided input, and I then have hooked up power, and I'm starting with plus 12 volts and simply ground. Here again was that pin out, so you can see I've looped back with a white wire like this. I'm sorry, the white wire up to here. The red wire carries power from VCC from the rail. This one labeled ground is on the blue wire, goes over, and then the output, although one loops around, the other one simply comes out on the white, and that's what I'm measuring. And you'll notice right away, without any buttons pushed, something interesting, and this is an issue with using op amps, which is that when you're not putting anything on the inputs, right, I have no signal coming into the input because none of the push buttons are being pushed. You see the voltage is at some random location and actually kind of drifting around a bit. This is something you usually put a pull-up or pull-down resistor in to deal with. We're only concerned with using this particular device when we push a button, so let's see what happens. Now the top one should give us 2 volts, and it is pretty much right on where it is supposed to be. The second one, however, should be 1 volt, and we notice it reads a little bit high. And the third one's supposed to be 0 volts, and it gives a completely wrong reading. Now there's a reason for this, and it has to do with how we've wired up this op amp. The moment it is being used with a single supply. So we have this on plus 12 and this on 0. And in fact, the TL081, like all op amps, really cannot take an output signal, say when it's supposed to be 0 volts, it's getting 0 volts in the input and trying to make the output equal to the input by the golden rules. It can't push all the way down to its lowest set point. It actually can't pull all the way up to its highest VCC either. There's some gap between the output and the power. So the output always has to range in between the power supplies. And that's why the TL081, like most of the op amps we'll use in this class, is actually a bipolar supply op amp, and instead of using ground, you have the option of using a minus VCC instead. So we're going to set that actually to minus 12 volts. Remember, we've set this to plus 12 volts already. And then just to sort of complete this little drawing, we've looped the output, as you know, either goes output on the white wire or back around to here. And this is from our voltage divider. All right. To do that, I'm going to move this then, which is the wire on minus VCC, over to actually the minus 12 volts. So as you recall, I have minus 12 volts coming in, that is the red stripe, typically, on the Eurorack power supply that goes onto this outer rail. And so that's where I got to get to. Still floating around, but now when I push the buttons, 0 is truly 0, 1 is truly 1, and 2 is truly 2. And you'll note that actually these voltages are now exactly the same as the ones I set up here, even to within a few tenths of a millivolts off, 0, 1, and 2. How does it perform? This again is our 10K load. So that's our 10K load. So we're taking this 10K and putting it to ground. And when we measure here at V out, we expect to see no change, even though this resistor is comparable to the Thevenin resistance from the voltage divider. We expect to see no drop. So again, simulate this is the load. Remember that this inner rail I have made to be the ground. So I put him across the output. Again, it's floating around now because there's no input. 0 truly gives me 0. 1 gives me 1. And 2 gives me 2. Actually, exactly what I put on the input, and the presence of this load doesn't matter a bit. So we've successfully buffered our output by using an op-amp and a follower or buffer configuration. V out equals V in. Our TH approaches 0, capable of driving any load, even a very relatively small load that takes a lot of current. It would normally have a lot of voltage drop. Putting these followers and buffers in the individual plugins in your Eurorack kits is a really great technique of eliminating voltage drops. That is, you put a plug-in in, something that's going to use this subsequent output. You don't want the signal to change because you've added something. There is a downside, and the downsides are covered in lots of textbooks on high-end audio systems and precision electronics. And the downside is that this is a power device. It does add noise to the system, as opposed to the passive components, which don't add any noise. Anytime you amplify, you add a bit of noise, but you gain something amazing in terms of simplicity and usability, which is the ability to deliver the voltage you think you are going to need.